Hello everyone, welcome to the video user guide for IKA Flow, a reaction system designed for flow chemistry applications. In this video, I will be walking you through the assembly and the operation for IKA Flow. The equipment in front of us is IKA Flow main housing, and as you can see, the system is very light and compact. The IKA Flow package also includes a glass bottle, a mixing chip, a pair of support screws, 3 on and off valves, a union, a heating block, 4 disc reactors, and a labeled tubing set. In order to run flow chemistry reactions, we recommend pairing IKA Flow with an IKA RCT digital stir plate. We hope this is very handy in your lab. To connect these two devices together, line up the threaded holes in RCT with the slots in IKA Flow support plates. Secure the connection by installing the support screws. Find the heating block and put it on RCT. Then slide the disc reactors into the heating block. Fill the bottle with the desired solvent. In this video, we are going to use tap water. For the safety reason, only the glass bottle supplied by IKA is recommended. Before closing the cap to the bottle, notice that one of the 3 ports has no additional tubing extending inside the bottle. Keep in mind with its position and connect this port with tubing A. During the operation, the gas from an external source goes through the tubing A, enters the bottle, pushes the solvent into tubings inside the bottle. Connect the other 2 ports on top of the cap with tubing 0. The solvent will come out from this end of tubing 0. The next step is to place the solvent bottle inside the main housing and to connect the tubings. First, push the doorknob and open the door. As you can see, there is a port located inside the main housing. Insert the open end of tubing A to this port, push it through. To make sure the connection is secured, gently pull the tubing. If it doesn't move, the connection is fastened. In order to uninstall tubing A from the main housing, notice that there is a little ring around the port. Press and hold this ring and pull tubing A. Put the glass bottle inside the main housing. Make sure it sits well within the bottle holder at the bottom. Organize tubing 0 with a shelf on the rooftop inside the main housing. Slide the tubing through the cutout and put them aside. Keep the open end of tubing 0 outside the main housing. Close the door, push the doorknob again. After the click sound, the door is locked. Grab two of the on and off valves, connect them to the open end of tubing 0. It doesn't matter which two valves are chosen because all of the on and off valves are identical. Behind the valve, there is a magnet attached. This is for easy assembly and space organizing. Follow the numbering system displayed on the main housing. Connect tubing 3 between the open end of on and off valve and part 3 of the injection valve. Open the lid on top of the main housing and use the top shelves to organize tubing 3. As you can see, part 3 can be easily identified from each injection valve. Repeat the same operation for the other side. Slide the mixing chip on top of the main housing. Follow the numbering indicators and connect tubing 4 between the inlet of the mixing chip and port 4 of the injection valve. Repeat the same operation for the other side. As mentioned earlier, the solvent comes through tubing 0, goes through on and off valve, and enters the injection valve through part 3. At the beginning of the operation, the injection valves are switched to load phase. In that phase, part 3 and part 4 are internally connected. The solvent passes by the inside path, exits through part 4, and enters the mixing chip. The next step is to insert the spools to each side of the main housing. The spools are wound around with tubing 2 and tubing 5. Connect tubing 5 to port 5 of the injection valve. Use a shelf to organize tubing 5. Route tubing 2 over the shelf and connect tubing 2 to the injection valve accordingly. Each spool has a loop volume of 2 ml. Repeat the same operation for the other side. Connect tubing 1 to port 1 of the injection valve. Organize tubing 1 with a shelf. Route the loose end of tubing 1 to a waste sink. Repeat the same operation for the other side and close the lid. Now all the parts of the injection valves are connected to the tubings. As mentioned earlier, the injection valves are switched to load at the beginning of the operation. While the solvent directly passes by part 3 and part 4, the samples enter the injection valve through part 6, come out through part 5, go through the sample loop, re-enter the injection valve through port 2, and exit through port 1. Once the sample is observed coming out from the loose end of tubing 1, the sample loop is fully loaded. Then the injection valves are switched to injection phase. What will happen is that the solvent plays a role of carrier, entering part 3, coming out from part 2, going through the sample loop, bringing the samples into part 5, and bringing them out from part 4. Port 4 is the exit of the injection valve, and liquid coming from port 4 enters the inlets of the mixing chip. For how the injection valve works internally in detail, please refer to IKA Flow menu. And the operating instructions of injection valve is included by the demonstration in later part of this video. Connect tubing 7 between the mixing chip outlet and one of the port of any disk reactor. Each part of the disk reactor can be used as the inlet of the reaction system. Use the hooks on the door frame to organize tubing 7. Depending on the experiment, connect tubing 8 between each reactor in series. You can use up to 4 reactors. Connect tubing 9 between the last disk reactor and the remaining on and off valve. Note that there is no tubing 6 for IKA Flow, so tubing 9 will be easily distinguished. Connect tubing 10 between the open end of on and off valve and the union. Connect tubing 11 to the open end of the union. Install the on and off valve to the main housing using the magnet. The loose end of tubing 11 goes to the product collection container. Make sure the air valve and the on and off valves are in the off position initially. Both injection valves are at the load phase. The indicators should be in the direction as shown in this video. Now that the system is completely assembled, let's run a demonstration with water as carrier and 2 different color beverages as the samples. The sample loop volume in the syringe should be in excess of the sample loop volume. Load the sample loop through port 6 of each injection valve. As you can see on the left side, the sample comes out from tubing 1 to the waste sink. The samples can be loaded either one by one or at the same time. After the sample loops are filled, disconnect the syringe from each valve. Connect the air inlet behind the system to a compressed gas source from the fume hood. In the demonstration, we are connecting it to an external air pump. If you wish to uninstall the hose, press and hold the ring while pulling the hose. Make sure not to exceed the maximum input pressure as specified in the menu. Set the working pressure using the pressure regulator and pressure gauge for reference. Set the air valve and the on and off valves to the on position. During the operation, the glass bottle should remain inside the main housing and the door should remain closed. In an actual reaction, set the safety temperature and reaction temperature on RCT. We will skip this step in this video. Instructions of setting safety temperature is included separately. Keep in mind that IKA Flow disk reactors have their maximum continuous use temperature printed on the cell surface. Please plan your experiments accordingly. For more information about RCT, please refer to RCT digital menu. Allow the solvent to flow through the system. Right now, the solvent is passing through the disk reactors and driving out the air bubbles inside. Once the disk reactors are completely filled and the solvent exits from tubing 11, simultaneously switch both the injection valves to the injection phase. As you can see, the solvent carries the samples to the mixing chip and carries the mixture of the samples out from the chip. This is the flow path in the disk reactor. The video is played with a faster speed for the convenience of observation. The mixture is pushed by the solvent, and it's pretty clear how the mixture enters and exits each reactor. The reactors will be filled with solvent after the mixture leaves. Collect the reaction mixture from tubing 11. For this demonstration, the samples are well mixed, and we can compare the color between the mixture and the original samples. Switch off the on and off valve momentarily once all the mixture is collected. Transfer the reaction mixture. During the cleaning process, find an empty container to collect the solvent. Switch off the gas supply and open the door of main housing. You will hear the sound of degassing upon pushing the doorknob. This is normal. Empty the solvent bottle and reinstall it to the main housing. Tubing 10, which is a capillary, is used to maintain a proper range of residence time during the reaction. To save your time, remove tubing 10 after it's flushed with solvent. Switch on the on and off valve. Now air is forcing the solvent out faster from the reactor. Leave the air on until it's completely dry inside. Later, reinstall tubing 10 to dry the inside of this capillary. Flush port 1, port 6, and tubing 1 using cleaning solvent, and use compressed air to blow and dry the remaining solvent. The cleaning procedure can also be found in IKA Flow menu. The safety temperature should be at least 15 degrees higher than the reaction temperature. In our case, the maximum continuous use temperature of PP disk reactor is 100 Celsius degree, meaning that once the surrounding temperature exceeds 100 degrees, the disk reactor will melt. Set safety temperature as 100 degrees by tuning with a screwdriver. Set the reaction temperature. As you can see, the set temperature cannot go higher than 85 degrees. This protects the reactors in case of a fluctuating